Welcome, everyone. In today's lecture, we're going to break down a core concept of artificial intelligence that's absolutely fundamental to understanding its true power and purpose. Now, to really get this right, we have to see AI not as some sudden invention, but as the next logical step in how humans have always solved problems. Think about it. We went from manual calculations to digital systems based on rules, and now we're in an era of intelligent systems that thrive in these incredibly data-rich environments. So our main goal today is to build a very clear, precise academic framework for understanding AI. And the key shift in thinking is this: AI is not a thinking machine. It is a powerful, systematic prediction engine. Okay, so let's dive right in with a foundational question that really gets to the heart of a huge misconception. Does AI actually make decisions? The answer is absolutely crucial for telling the difference between real AI and just a fancy form of automation. A traditional computer program, it just follows the explicit rules someone wrote for it. An AI system, on the other hand, learns. And what it learns to do, as we're about to see, isn't to decide, but to inform the decisions that we make.
Now, this slide right here presents a really critical shift in perspective. The common view, the one you see in movies and read about online, it imagines AI as this autonomous decision maker, right? Like a robot brain calling the shots. But a much more accurate and frankly more useful way to think about it is to see AI as a powerful prediction tool. It gives us this crucial, data-driven ingredient for our decisions, but it doesn't make the final call itself. And understanding this distinction is absolutely vital for anyone who plans on using AI effectively in their field.
So let's really dig into this distinction because it's so important. The main output of modern AI systems isn't a command or a final decision. It's a prediction. And we need to be really precise about what we mean by the word prediction in this very technical context.
Academically speaking, prediction is not about staring into a crystal ball and seeing the future. No, the definition is way more practical. Prediction is simply the process of generating missing information from the information you already have. It is fundamentally about using data to fill in the blanks. And that is what separates AI from old-school software. Traditional software needs a pre-written rule for every single possible blank. AI, on the other hand, learns the rules for filling in those blanks all by itself.
So a really crucial point here is that AI outputs are not these absolute deterministic commands. They are probabilistic forecasts. Their entire purpose is to reduce our uncertainty by calculating the likelihood of different outcomes. They give us better, data-driven information to work with. And in an era like ours, defined by constant change and competition, the ability to systematically reduce uncertainty, well, that's a profound economic advantage. This is a perfect illustration of the concept. An AI, specifically a type of narrow AI that's really good at one specific task, doesn't shout, "Shut down the supply chain." No, instead, it gives you a quantified likelihood. This output, this probability, is the missing piece of information. A human manager can then take this prediction and combine it with their own experience, with their knowledge of the context, to make a really smart strategic decision. Okay, so let's examine the mechanics of this whole process. How does an AI system actually take all that existing data and use it to fill in those informational blanks to generate these powerful forecasts? Well, it involves a few core components that have to work together in sequence. At its heart, it's really a three-stage process. First, the system is fed enormous amounts of input data, which we often call training data. Second, a learning algorithm goes to work on this data, identifying patterns and relationships that a human being might never, ever see. And third, the output of all that training is something called a model, which is basically a complex statistical representation of all the patterns from the data. That model is the thing that can then generate a prediction when you give it new information. Now, just take a second to consider the sheer variety of what we're calling input data. This can be anything from highly structured information like transaction logs, all the way to unstructured data like the text from emails or subtle signals from the market. The really unique capability of modern AI, which is only possible because of massive computational power, is its ability to swallow and find patterns across this immense volume and variety of data. And this leads us to what is perhaps the foundational principle of all machine learning. The quality of any prediction is fundamentally tied to the quality of its input data. You've probably heard the old saying, garbage in, garbage out. Well, in AI, that's an academic axiom. If your training data is incomplete, or it's biased, or just plain old and outdated, the predictions that come out of your model will be unreliable. It doesn't matter how sophisticated your algorithm is. So this brings us to a really vital question about our own role in this whole process. If the AI is providing the predictions, what's left for us to do? This is where we make the jump from prediction to action, and it's where the human element becomes absolutely essential for accountability and for getting good outcomes. Let's really analyze this carefully. If the machine's primary function is to generate a probabilistic forecast, what then is the human's function? Where do we, as students, as future professionals and leaders, fit into this new AI-augmented workflow?
Well, it turns out our role becomes even more critical. It takes human judgment, domain expertise, an understanding of the strategic context, and ultimate accountability. It takes all of that to translate a raw prediction into a valuable action. The prediction is a sophisticated input into our decision-making process, but it is not a replacement for it. At the end of the day, we are responsible for that final decision. And this quote right here, it just perfectly frames the central challenge for any organization that's trying to implement AI. The goal isn't just to buy better prediction technology. No, the real work is to completely redesign your workflows to create a kind of partnership, one that leverages these machine-generated estimates to produce better outcomes, all while keeping and even enhancing human judgment and responsibility. All right, let's bring it all home. Let's conclude by summarizing why this reframing of AI from a decision maker to a prediction engine is just so essential to grasp. The ultimate goal here is to augment human intelligence, to enhance our own cognitive capabilities, not to replace them. It's a really simple but incredibly powerful causal chain. When we have access to better, faster, and cheaper predictions, we are empowered to make more informed choices. The AI doesn't make the choice for us, but it radically improves the quality and the scope of the information we use for our own decision-making process. And that, of course, leads to far superior outcomes. The economic value of AI stems directly from this idea. It makes prediction, which is a core part of almost every business function, radically cheaper. Reducing uncertainty is critical in fields like finance and logistics. Augmenting human expertise is transforming medicine and engineering. And this unlocking of totally new strategic possibilities, well, that's how organizations and individuals are going to maintain their competitive edge in the future. So this leaves us with a final provocative thought to take away from our lecture today. If you had a tool that could generate any missing piece of information, a tool that could fill in any blank to reduce uncertainty, what is the most valuable prediction you would seek? In your field of study, in your future career, or in our society as a whole? What would you ask it to predict?